Okay, now the fourth quantum number, that is spin quantum number. Yesterday we have discussed about this magnetic quantum number, and this is the last quantum number, which is called spin quantum number, and it is represented by the symbol ms. So what represent by this quantum number? Actually this quantum number represent about the spin of electrons. What type of spinning of the electron you can find out from this quantum number. As I have told you, an orbital contain maximum 2 electrons, and when an orbital contain 2 electrons, then the spin of the 2 electrons should be opposite from one another. If an electron spin in clockwise direction, then the other electron will spin in anti-clockwise direction. So from this quantum number, you can find out about the spin of electron. So this quantum number gives the idea about the spin of electrons. If an orbital contain 2 electrons, then the spin of the 2 electron should be opposite from one another. If an electron spins in clockwise direction, then other electron will spin in anti-clockwise direction. This quantum number, I mean ms, can have only two values. That is plus half for clockwise and minus half for anti-clockwise. So this is about the spin quantum number. This quantum number represent about the spin of electron, and when an orbital contain 2 electrons, then the spin of the 2 electrons should be opposite from one another. If one spin in clockwise direction, then the other electron will spin in anti-clockwise direction. Because if the spin of both the electrons are same, then some repulsion takes place. So that is why their spin should be opposite from one another. And if you want to write the value, ms have only two values, that is plus half. If the electron spins in clockwise direction, you write plus half, and if it spins in anti-clockwise direction, then you have to write minus half. So this is about the quantum numbers, 4 quantum numbers. So the first quantum number, that is principal quantum number, which represent about the cells of an atom, the main cells. The second quantum number, azimuthal quantum number, represent about the subcells. The third quantum number, magnetic quantum number, represent about the orbitals. And the fourth quantum number, the spin quantum number, represent about the spin of electrons. Now, this type of question you may get from the quantum numbers. The question is, an electron is present in 4f subcell. Write the possible quantum numbers. Write the possible quantum numbers for the electron. So this type of question may asked. So to write the answer of this question, the electron is present in 4f subcell. You can represent it like this: 4f contain 1 electron. Now you have to write the quantum numbers. So first time you have to write the principal quantum number n. Since it is 4f, this 4 represent the cell, this 4 represent the principal quantum number, so n value should be 4. What about the L value? L represents subcell. What is our subcell? The subcell is F subcell, and for F subcell, L value is always 3. Now what is the ML value? You know ML is determined from L. There is a formula twice L plus 1. So when you put twice L plus 1, you will get 7, and the value should be minus L to plus L, minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. So there are 7 orbitals inside F. And if you want to write spin ms, as you know, ms have only 2 values, that is plus half and minus half. And I have told you, if an orbital contains 2 electrons, one in clockwise, another should be in anti-clockwise. But here the subcell contains only 1 electron. When an orbital or subcell contains 1 electron, then the spin may be clockwise, it may be anti-clockwise. That is why when you write the value, you have to write like this: plus half or minus half. Don't write plus half and minus half. If you write and, then it represents 2 electrons. So the spin may be clockwise or may be anti-clockwise because only 1 electron is present. So this type of question may ask in your exam. Another question: designate the subcell. Designate the subcell. N equal 2, L equal 1. N equal 3, L equal 0. N equal 5, L equal 3. N equal 4, L equal 2. This type of question also you may get. The principal quantum number and azimuthal quantum numbers are given. You have to represent the subcell. What subcell represent by this quantum number, by this quantum number, by this quantum number. So if you want to write the answer for this question, you know first quantum number represents cell, second quantum number represents subcell. So here second quantum number, I mean azimuthal quantum number value is given 1, and when L is 1, the subcell is represented by P subcell, and since it is present in second cell, that's why the name of the subcell will be 2P, I mean second cell P. In the second one, L equals 0. L equals 0 means always represent S subcell, and it is present in third cell, that's why you have to represent as 3S. Now L equals 3. When L equals 3, subcell is named as F, you know, and the cell number is 5, N equals 5, that's why it is represented as 5F. Here L value is 2, L value 2 means it is D. N value how much? N value 4. So you can represent by 4D. So like this way you can represent the subcell. These are the name of subcell, not the orbital, these are subcell. So if you know about the first quantum number and the second quantum number, then you can find out the number of subcell. Now another question may ask, a question asks like this: why 2D subcell does not exist? 2D subcell does not exist. Answer you have to write like this: in 2D, N value is 2. If N is 2, L you will get 2 values, one is 0, one is P. For 0 you will get S, which is called 2S, and for 1 you will get P, that is 2P. So there will be no D here. So that is why in second cell you don't get D subcell, and that is why 2D subcell does not exist. Like this way you have to write the answer. Thank you.